March 23, 1945. The Rhine River, Germany's last natural fortress, stretched black and cold beneath a moonless sky. Its waters churned with the memory of 1,000 years of war. The current moved at 5 miles per hour, fast enough to sweep a man downstream in seconds, strong enough to snap steel cables like thread. On the western bank, hidden beneath camouflage nets and the cover of darkness, thousands of British soldiers waited in silence. The air smelled of diesel fuel, wet earth, and fear. They had been told the crossing would be impossible. The river was too wide, too fast, too heavily defended. German artillery lined the eastern shore like teeth in a predator's jaw. Machine gun nests dotted every ridge, every hilltop, every conceivable firing position. Minefields stretched for miles inland, marked only by the occasional skull and crossbones sign that the Germans had posted as a grim warning. Concrete bunkers, reinforced with steel and earth, housed 88mm anti-tank guns that could punch through armor at 1,000 yards. And yet, in the pre-dawn silence, a different kind of army was assembling. Not infantry with rifles, not tankers with cannons, but engineers, sappers, men who built bridges out of steel and stubbornness, who carried wrenches instead of rifles and blueprints instead of battle plans. Men who understood that war was not just about destroying, but about creating, about connecting one side to the other when everyone said it couldn't be done. Among them stood Sergeant Major William Harding, a 31-year-old civil engineer from Yorkshire who had spent the last 3 months planning something the German High Command believed was physically impossible. A bridge. Not just any bridge, but a Bailey Bridge, a modular marvel of British engineering that could be assembled in sections, piece by piece, under fire, in darkness, across one of the most dangerous rivers in Europe. The Bailey Bridge was revolutionary. Invented in 1940 by Donald Bailey, a civil servant who had never built a bridge in his life, it consisted of prefabricated steel panels that could be bolted together by hand. No welding required, no cranes needed, just men, muscle, and mathematics. Each panel weighed 600 pounds and measured 10 feet long by 5 feet high. They could be stacked, doubled, tripled, configured in dozens of ways depending on the load and the span. A single-layer Bailey Bridge could support a jeep. A double layer could support a tank. And if you knew what you were doing, if you had trained your men properly, if you had calculated every variable correctly, you could build one in hours instead of weeks. But that wasn't the impossible part. The impossible part was doing it in one night, without being seen, without being heard, without losing a single section to the current or a single man to enemy fire. The impossible part was building it across 400 yards of fast-moving water while German artillery zeroed in on your position. The impossible part was doing it in complete darkness, with only shielded lanterns and hand signals, while the fate of an entire army depended on your success. Harding stood at the water's edge, boots sinking into the cold mud, watching the current. His hands trembled, not from fear, though fear was certainly there, but from the weight of what was about to happen. Behind him, 200 sappers waited for the signal. These were not ordinary soldiers. They were carpenters, welders, mechanics, civil engineers, men who in peacetime had built houses, repaired cars, designed bridges, men who understood load-bearing calculations and stress tolerances and the way steel behaved under pressure. Men who had volunteered for this mission knowing full well that they might not survive it. Beside Harding, amphibious tanks called buffaloes idled in the shadows, their engines rumbling like distant thunder. these strange vehicles, part tank and part boat, would ferry the first wave of infantry across the river. They were ungainly, slow, vulnerable, but they could swim. And tonight, that was all that mattered. In Harding's pocket, folded and refolded a dozen times until the creases had worn thin, was a handwritten note from his commanding officer, Major General Thomas Rennie. The note was brief, just 2 sentences, but Harding had memorized every word. "If this works, you'll change the war. If it doesn't, we'll all be dead by sunrise." Harding looked at his watch. The luminous hands glowed faintly in the darkness. 2 a.m. 4 hours until dawn. 4 hours to build the impossible. 4 hours to prove that engineering could triumph over artillery, that planning could overcome chaos, that a group of men with wrenches could do what an entire panzer division could not stop. He turned to his men, these quiet heroes who would never make the history books, who would never have their names carved in marble or their faces printed in newspapers. He looked at their faces, pale in the darkness, eyes wide with anticipation and dread. And he whispered the words that would echo through history, words that would be repeated in engineering schools and military academies for decades to come. "Right then, lads, let's get to work." The man who built bridges in his sleep. William Harding wasn't born a soldier. He was born a builder, and that distinction mattered more than anyone realized. His father, Thomas Harding, ran a small construction firm in the hills outside Sheffield, a city famous for its steel mills and its stubborn, practical people. His mother, Margaret, kept the books and raised 4 boys in a modest stone house that smelled perpetually of sawdust, machine oil, and strong tea. William was the eldest son, born in 1914, just as the Great War was beginning. He grew up in the shadow of that war, watching men return from the trenches with haunted eyes and missing limbs, listening to stories of mud and blood and senseless death. He learned early that war was not glorious. It was wasteful. And waste, to a builder's son, was the greatest sin. By age 12, William could read a blueprint faster than most men could read a newspaper. He understood instinctively how weight distributed across a beam, how tension and compression worked in harmony, how a structure could be both strong and elegant. By 15, he was designing load-bearing structures for local warehouses, calculating stress tolerances in his head while other boys his age were playing football. By 20, he had earned a degree in civil engineering from the University of Leeds, graduating top of his class with a thesis on modular bridge construction that his professors called visionary. He took a job with a railway company, designing bridges across the north of England, small bridges mostly, spans across rivers and valleys, nothing dramatic. But he loved the work. He loved the precision of it, the way mathematics translated into physical reality, the satisfaction of seeing something he had imagined on paper become solid and real. He loved bridges. Not for their beauty, though he appreciated that. Not for their grandeur, though some were certainly grand. He loved them for their logic, for the conversation they represented between gravity and geometry, between human ambition and natural law. A bridge, he once told his younger brother, is a conversation between gravity and geometry. If you listen carefully, it will tell you exactly what it needs. You just have to be patient enough to hear it. When war broke out in September 1939, Harding didn't rush to enlist. He wasn't a pacifist, but he wasn't a fighter either. He believed in solving problems, not creating them. He believed in building, not destroying, But by the summer of 1940, after Dunkirk, after watching the British Expeditionary Force limp home across the Channel in fishing boats and pleasure craft, after the Blitz began and German bombs rained down on British cities night after night, he realized that sometimes the only way to preserve what you loved was to fight for it. He walked into a recruitment office in Sheffield on a gray morning in August 1940 and asked where they needed engineers. The recruiting sergeant, a grizzled veteran of the Great War with a missing eye and a thick Yorkshire accent, looked him up and down and said, "Can you build a bridge under fire?" Harding thought about it for a moment, then nodded. "I can build a bridge anywhere." The sergeant grinned. "Then you're going to the Royal Engineers, son, the sappers. Best damn unit in the British Army." He was right. The Royal Engineers, known as the sappers, were the men who built roads through jungles, cleared mines from beaches, constructed airfields in deserts, and yes, built bridges under fire. They were not frontline troops, but they were always at the front, working in the most dangerous places, doing the most essential jobs. Without them, armies couldn't move. Without them, wars couldn't be won. Harding thrived in the sappers. He was calm under pressure, precise under chaos, and had an uncanny ability to visualize structures in 3 dimensions. He could look at a river and see the bridge that needed to span it. He could look at a pile of steel panels and see how they fit together. He could look at a problem that seemed impossible and find a solution that seemed obvious once he explained it. His superiors noticed. By 1942, he was a sergeant, leading a section of sappers in North Africa, building bridges across wadis and repairing roads that had been bombed by the Luftwaffe. By 1943, he was a sergeant major, training new recruits in the art of field engineering. And by early 1945, he was one of the most trusted field engineers in the British Army, a man who had built bridges in the desert heat of Libya, the mountain cold of Italy, and the muddy fields of France. But it wasn't just his technical skill that set him apart. It was his philosophy. Harding believed that war was won not by the loudest guns or the biggest bombs, but by the quietest solutions. He believed that the best weapon was not a rifle or a tank, but a well-built bridge that allowed your army to move faster than the enemy expected. He once told a young sapper who was complaining about the tedium of construction work, "Any fool can blow something up. It takes a craftsman to build something that lasts, and in war, the things that last are the things that win." And now, standing on the banks of the Rhine in the cold darkness of March 23, 1945, he was about to put that philosophy to the ultimate test. He was about to build something that would last just long enough to change the course of history. The river that couldn't be crossed. The Rhine was more than a river. It was a symbol, a legend, a line drawn across the map of Europe by geography and history. For 2,000 years, it had been the dividing line between empires, cultures, and armies. The Romans had built forts along its banks and called it the edge of civilization. Charlemagne had crossed it to unite his empire. Napoleon had crossed it to conquer Germany. And now, in March of 1945, it stood as Germany's last line of defense, the final barrier between the Allied armies and the heart of the Third Reich. The Rhine was not just wide, it was formidable. In some places, it stretched 400 yards from bank to bank, wider than 4 football fields laid end to end. The water was deep, 15 feet in most places, 30 feet in the center channel. The current was fast, moving at 5 miles per hour, fast enough to sweep away a man in seconds, strong enough to drag a boat downstream before it could reach the other side. The water was cold, barely above freezing, cold enough to kill a man from hypothermia in minutes. And the river was unpredictable. Spring rains had swollen it beyond its normal banks. Debris floated in the current, logs and branches and the wreckage of blown bridges, all of it capable of smashing into a boat or tangling in a propeller. But the river itself was only part of the problem. The real problem was what waited on the other side. The Germans had spent months fortifying the eastern bank. They had built concrete bunkers, reinforced with steel and buried under earth, each one housing machine guns or anti-tank weapons. They had dug trenches in zigzag patterns, connected by communication tunnels, creating a network of defensive positions that could support each other. They had strung barbed wire across every approach, triple rows of it, rusted and tangled and nearly impossible to cut. They had planted mines, thousands of them, anti-personnel mines that would blow a man's leg off, anti-tank mines that could flip a Churchill tank like a toy. They had positioned artillery, 80-mm guns, and 105mm howitzers, pre-sighted on every likely crossing point, ready to rain shells down on anyone foolish enough to try. And they had blown every bridge. As the German army retreated across the Rhine in the winter of 1945, they systematically destroyed every bridge behind them. Ancient stone bridges that had stood for centuries were packed with explosives and blown into rubble. Modern steel bridges were cut with torches and dropped into the river. Railway bridges, road bridges, footbridges, all of them gone. The Germans believed the Rhine was uncrossable, and they were almost right. The Allies had tried before. In early March, American forces under General Courtney Hodges had captured the Ludendorff Bridge at Remagen, a railway bridge that the Germans had failed to destroy in time. It was a stroke of incredible luck, and the Americans poured across it, thousands of troops and hundreds of vehicles, establishing a bridgehead on the eastern bank. But the bridge had been damaged by German demolition attempts, and it was never designed to carry the weight of heavy tanks. Engineers worked around the clock to reinforce it, but the damage was too severe. On March 17th, 10 days after its capture, the Ludendorff Bridge collapsed into the Rhine, killing 28 American engineers who were working on it at the time. It was a stark reminder that the Rhine did not forgive mistakes, that bridges were fragile things even when they looked solid, that engineering was not just about building, but about understanding the limits of materials and the forces that acted upon them. Now, in late March, British Field Marshal Bernard Montgomery was planning the largest river crossing since D-Day, Operation Plunder. The name was deliberately understated, typical of Montgomery's dry sense of humor. But there was nothing understated about the operation itself. It involved two entire armies, the British Second Army and the American Ninth Army, over 250,000 troops, thousands of vehicles, hundreds of boats and amphibious craft, and the largest airborne assault since Normandy. The goal was simple. Get an entire army across the Rhine in one night, establish a bridgehead on the eastern bank, and break through the German defenses before they could organize a counterattack. Execution was anything but simple. Montgomery's plan was meticulous, almost obsessively detailed. He had spent weeks studying the Rhine, analyzing aerial photographs, interviewing local civilians who knew the river, consulting with engineers about currents and depths and soil conditions. He had stockpiled supplies, ammunition, fuel, medical equipment, everything an army would need once it crossed. He had assembled a fleet of amphibious vehicles, buffaloes and DUKWs and storm boats, enough to ferry thousands of troops across the water. He had coordinated with the Air Force to provide cover and to drop paratroopers behind German lines. He had even arranged for artificial moonlight, searchlights pointed at the clouds to create a diffuse glow that would help his troops see without giving away their positions. But the key to the entire operation, the linchpin that everything else depended on, was the bridge. Without a bridge, tanks couldn't cross. Without tanks, the infantry would be slaughtered by German armor. Without engineers, there would be no bridge. And that's where William Harding came in. The Bailey Bridge, a marvel in pieces. The Bailey Bridge was one of those inventions that seemed so simple, so obvious in retrospect, that people wondered why no one had thought of it before. But like all great inventions, it was the product of one man's insight and determination. Donald Bailey was a civil servant in the British War Office, a quiet, unassuming man who had never built a bridge in his life. But in 1940, as Britain faced the threat of invasion and the army desperately needed a way to replace bombed bridges quickly, Bailey had an idea. What if, instead of building bridges on site with cranes and concrete and weeks of labor, you could build them in factories, in sections, and then assemble them like a giant erector set? What if each section was light enough to be carried by hand, but strong enough to support a tank? What if the sections could be bolted together without welding, so that anyone with basic training could assemble them? What if you could build a bridge in hours instead of weeks? Bailey sketched his idea on a piece of paper and submitted it to the War Office. Most of his colleagues dismissed it as impractical, but one engineer, a man named Morris Denny, saw its potential. He helped Bailey refine the design, and by 1941, the first Bailey Bridge was being tested. It exceeded all expectations. The design was brilliant in its simplicity. Each panel was a rectangular frame made of steel, with a lattice of cross-bracing for strength. The panels were 10 feet long and 5 feet high, and they weighed 600 pounds, heavy enough to be sturdy, but light enough for 6 men to carry. The panels had pins at the corners that fit into sockets, allowing them to be connected like Lego blocks. You could stack them vertically to increase height, or horizontally to increase width. You could double or triple the layers to increase load capacity. A single-layer Bailey Bridge could support 10 tons. A double layer could support 40 tons, enough for a Churchill tank. A triple layer could support 70 tons, enough for the heaviest vehicles in the Allied arsenal. But the real genius of the Bailey Bridge was its versatility. It could span almost any distance, from 30 feet to over 200 feet, depending on how many panels you used. It could be built on dry land and then launched across a gap, or it could be built directly over water using pontoons for support. It could be assembled in any weather, in any terrain, by men with minimal training. And if a section was damaged, you could simply unbolt it and replace it with a new one. By 1945, Bailey bridges were being used all over the world. In North Africa, they spanned wadis and ravines. In Italy, they crossed mountain gorges. In France, they replaced bridges that the Germans had destroyed. General Eisenhower called the Bailey Bridge one of the 3 most important technological developments of the war, along with the radar and the atomic bomb. Field Marshal Montgomery, not known for praising anyone, said, "Without the Bailey Bridge, we would not have won the war in Western Europe." But building a Bailey Bridge across the Rhine was a different challenge altogether. The river was too wide for a single span. The current was too strong for simple pontoons. The German defenses were too formidable to allow for leisurely construction. Harding had spent 3 months planning every detail. He had calculated the exact number of panels needed, 240, enough to span 400 yards with a double-layer design for maximum strength. He had designed a launching system, a ramp on the western bank that would allow the bridge to be pushed forward, section by section, across the river. He had requisitioned pontoons, inflatable rubber boats that would support the bridge until it reached the other side. He had trained his men until they could assemble a panel blindfolded, until they could work in complete darkness using only touch and memory. He had calculated the river's current, the depth, the wind speed, the weight of the mud on the soldiers' boots. He had even accounted for the expansion and contraction of the steel in the cold night air. But there was one variable he couldn't control, one factor that could destroy everything, no matter how well he planned. The Germans. If they spotted the bridge before it was finished, if they realized what was happening, they would shell it into oblivion. And everyone on it would die. Harding knew this. His men knew this. But they also knew that without the bridge, the entire operation would fail. Thousands of soldiers would be stranded on the eastern bank, cut off from supplies and reinforcements, easy targets for German counterattacks. The Rhine crossing, the operation that was supposed to end the war, would become a disaster. So they had to build the bridge. They had to build it fast. They had to build it in the dark. And they had to build it right, because there would be no second chance. The night begins. 2 a.m. The signal came not with a shout or a whistle, but with a simple raised hand in the darkness. Harding saw it, a pale shape against the black sky, and he turned to his men. They were already moving, shadows in the night, each man knowing his role, each man carrying his burden. The first wave of amphibious vehicles, the buffaloes, rolled forward with a low rumble that seemed impossibly loud in the silence. These were strange machines, ungainly and awkward-looking, part tank and part boat. Officially called Landing Vehicle Tracked, or LVT, they had been designed by the Americans for island hopping in the Pacific, for landing troops on beaches defended by Japanese machine guns. But tonight, they would cross a river in the heart of Europe. Each buffalo carried 30 soldiers, packed shoulder to shoulder in the open cargo bay. The men sat with their rifles clutched across their chests, their faces pale and drawn. Some were veterans of Normandy, of the long slog across France, of a dozen battles whose names they could barely remember. Others were replacements, young men barely out of training, who had never seen combat, who had never crossed a river under fire. They all looked terrified, and they had every right to be. The buffaloes rolled down the muddy bank and into the water with a splash that seemed to echo across the river. The engines roared, the tracks churned, and slowly, painfully slowly, the vehicles began to move across the Rhine. They were not fast. In the water, a buffalo could manage maybe 5 miles per hour, barely faster than the current. They wallowed and pitched in the waves, water sloshing over the sides, soaking the men inside. The drivers, peering through narrow vision slits, could barely see where they were going. And then the Germans noticed. A flare shot up from the eastern bank, a brilliant white star that hung in the sky and turned night into day. In its harsh light, the buffaloes were exposed, vulnerable, sitting ducks. Machine gun fire erupted from the German positions, a chattering roar that seemed to come from everywhere at once. Tracer rounds, glowing red and orange, arced across the water like deadly fireflies. Bullets pinged off the armor of the buffaloes, ricocheting into the darkness. Some found gaps in the armor, punching through the thin steel, and men screamed. But the buffaloes kept moving. The drivers, hunched over their controls, kept the engines roaring, kept the tracks churning. The soldiers inside, crouched as low as they could, prayed and cursed and held on. One buffalo took a direct hit from a mortar shell. It exploded in a gout of flame and smoke, and then it was gone, sinking beneath the black water, taking its cargo of men with it. But the others kept going. Behind them, on the western bank, Harding watched through binoculars, his heart pounding. He counted the buffaloes as they crossed. 1, 2, 3, 4. He saw the explosion, saw the buffalo disappear, and he felt a cold fist clench in his stomach. But he kept counting. 5, 6, 7. The buffaloes were reaching the eastern bank now, their tracks finding purchase on the muddy slope. The ramps dropped, and the infantry poured out, scrambling up the bank, rifles raised, disappearing into the darkness. More flares went up. More machine gun fire. But the infantry kept moving, spreading out, finding cover, returning fire. They were establishing a perimeter, a fragile foothold on the eastern bank. And that foothold was what Harding needed, because without it, the bridge would be useless. He turned to his second-in-command, Lieutenant James Caldwell, a wiry Scotsman with a talent for logistics and a dry sense of humor. Caldwell had been with Harding since North Africa, had built bridges with him in the desert and the mountains and the mud. He was the best sapper Harding had ever worked with, and he trusted him completely. "Right, Jim," Harding said, his voice steady despite the chaos around them. "Let's start the bridge." Caldwell nodded, his face grim. "Aye, sir. Let's hope the bastards don't notice." But of course the Germans would notice. The question was not if, but when, and whether the bridge would be finished before they could destroy it. The first panel was already in position, hidden beneath camouflage netting on the western bank. It had been pre-assembled earlier that evening, bolted together by men working in complete darkness, their fingers numb from the cold. Now, 12 men lifted it, grunting under the 600-pound weight, and carried it to the launching ramp. The ramp was a simple structure, just steel beams angled down into the water, but it was essential. It allowed the panels to be pushed forward, one at a time, across the river, like a giant tongue extending into the darkness. Harding watched as the first panel was positioned on the ramp. The men worked in silence, their movements practiced and efficient. Bolts were tightened with wrenches that had been wrapped in cloth to muffle the sound. Pins were locked into place with a soft click, and then, slowly, carefully, the panel was pushed forward. It slid down the ramp and out over the water, supported by pontoons that had been floated into position earlier. The pontoons were inflatable rubber boats, each one about 15 feet long and 5 feet wide. They had been anchored to the riverbed with steel cables attached to concrete blocks. The cables had to be exactly the right length, long enough to allow the pontoons to rise and fall with the current, but short enough to keep them from drifting downstream. Harding had calculated the length based on the depth of the river and the angle of the current. He had tested his calculations a dozen times on paper, but this was the first time he would see if they worked in reality. The first panel settled onto the pontoons with a soft thump. The pontoons dipped under the weight, but they held. Harding exhaled. Breath he hadn't realized he was holding. It was working. So far. He checked his watch. 2:30 a.m. 3.5 hours until dawn. They were on schedule. Barely. The rhythm of construction. Building in the dark. Building a bridge in the dark is like conducting an orchestra without sound. Every man has a role. Every movement must be precise. Every action must be coordinated with the actions of others. One mistake, one dropped bolt, one misaligned panel, and the entire structure collapses. Or worse, it collapses with men on it. Harding moved among his men, checking, adjusting, encouraging. He didn't shout. He didn't need to. These men knew their jobs. They had trained for this, had practiced until the movements were automatic, until they could work in complete darkness using only touch and memory. But training and reality are different things. The river was louder than expected, a constant roar that made communication difficult. The current pulled at the pontoons, threatening to drag them downstream despite the anchors. The wind picked up, making the panels sway as they were carried forward. And every few minutes, a German flare would arc across the sky, forcing everyone to freeze, to become statues, to hope that the Germans wouldn't notice the bridge slowly extending across the river. But they kept working, panel by panel, bolt by bolt. Each panel had to be carried from the stockpile to the launching ramp, a distance of about 50 yards. 6 men to a panel, 3 on each side, lifting in unison, moving in step. If one man stumbled, if one man lost his grip, the panel would fall, and 600 pounds of steel would crush whoever was beneath it. At the ramp, the panel had to be positioned exactly, aligned with the previous panel so that the pins would fit into the sockets. If the alignment was off by even an inch, the pins wouldn't fit, and the panel would have to be repositioned, wasting precious time. Once aligned, the bolts had to be tightened, 4 bolts per connection, 16 connections per panel. The men used torque wrenches, tightening each bolt to exactly the right tension. Too loose, and the panel would wobble. Too tight, and the bolt might snap under load. And then the panel had to be pushed forward, out over the water, onto the pontoons. This was the most dangerous part. The panel had to be pushed smoothly, steadily, without jerking or twisting. If it twisted, it might slip off the pontoons. If it jerked, it might break a connection. And if it fell into the river, it would sink, and they would have to start over. By 3:00 a.m., the bridge extended 50 yards into the river. By 3:30, it was halfway across. The men were exhausted. Their hands were raw from handling the cold steel. Their backs ached from lifting and carrying. Their legs trembled from standing on the swaying bridge. But they didn't stop. They couldn't stop. Because on the eastern bank, the infantry was fighting for their lives. Harding could hear the battle, the rattle of machine guns, the crump of mortar shells, the occasional boom of a tank gun. The infantry had secured a small perimeter, but the Germans were counterattacking, trying to push them back into the river. If the infantry failed, if they were overrun, the bridge would be useless. Worse than useless. It would be a target, a perfect target for German artillery. "Faster," Harding whispered to Caldwell. "We need to go faster." Caldwell nodded and moved down the line, urging the men on. The pace quickened. Panels were carried faster, almost at a run. Bolts were tightened quicker, with less care for precision. The bridge grew, extending further and further across the dark water. But then, at 4 a.m., disaster struck. One of the pontoons broke free. The current had been pulling at it for hours, straining the anchor cable, and finally, the cable snapped. The pontoon drifted downstream, and the bridge sagged. For a moment, everything stopped. The men stared at the gap, at the section of bridge that was now unsupported, dipping towards the water. If the bridge collapsed now, if the panels broke apart, they would have to start over. And there was no time to start over. Dawn was less than 2 hours away. Harding didn't hesitate. He grabbed a rope from the supply pile, tied it around his waist, and jumped into the water. The cold hit him like a physical blow, driving the air from his lungs, making his muscles seize. The current grabbed him immediately, pulling him downstream, away from the bridge. But he kicked hard, swimming with all his strength, fighting the current, reaching for the loose pontoon. It was drifting about 20 yards downstream, bobbing in the waves. Harding swam harder, his arms and legs burning, his lungs screaming for air. He reached the pontoon, grabbed the anchor line, and pulled. The line was heavy, weighted down by the concrete block on the riverbed. He pulled hand over hand, dragging the pontoon back upstream, back toward the bridge. Behind him, other sappers had jumped into the water to help. Together they dragged the pontoon back into position, fighting the current every inch of the way. They re-anchored it, using a spare cable from the supply pile, tying it off with knots that would hold even in the strongest current. Harding climbed out of the water, shivering, gasping, his uniform soaked and heavy. Caldwell handed him a blanket and a flask of rum. "You're mad, sir," Caldwell said, his voice a mixture of admiration and exasperation. Harding took a swig of rum, feeling the warmth spread through his chest. He grinned, his teeth chattering. "Probably, but we're still on schedule." By 5 a.m., the bridge was 3/4 complete. The eastern bank was in sight, just 100 yards away. The men could see the infantry waving them on, urging them forward. But the Germans had noticed. Artillery shells began to fall, not close, not yet, but close enough to send up geysers of water and mud. The sappers worked faster, driven by fear and adrenaline. Panels were slammed into place, bolts barely tightened before the next panel was pushed forward. And then, at 5:45 a.m., just as the first light of dawn touched the eastern horizon, the final panel locked into place. The bridge was complete. Harding stood at the center of the bridge, breathing hard, staring at what they had built. 400 yards of steel and stubbornness, stretching across the Rhine like a defiant finger pointed at the German army. A bridge that shouldn't exist, that the Germans had said was impossible, that his own superiors had doubted could be built in one night. But it did exist. It was real. It was solid. And it was beautiful. Caldwell came up beside him, his face streaked with mud and sweat. "We did it, sir. We actually did it." Harding nodded, too exhausted to speak. He looked at his watch. 5:47 a.m., 13 minutes ahead of schedule. He allowed himself a small smile, and then he heard the sound of engines, the deep rumble of tanks, and he knew that the real test was about to begin. The tanks roll, 6 a.m. The first tank crossed at exactly 6 a.m., just as the sun broke over the horizon, painting the sky in shades of orange and pink. It was a Churchill, a British heavy tank, 40 tons of steel and firepower, with a 75 mm gun and armor thick enough to stop most German anti-tank rounds. The crew was nervous. They had been told the bridge could hold them, that the engineers had calculated the load capacity, that the structure was sound. But seeing it, This thin line of metal panels stretched across a raging river, supported by nothing but inflatable rubber boats, was another thing entirely. The tank commander, a lieutenant named Peter Ashford, stood in the turret, looking at the bridge with undisguised skepticism. "You're sure about this?" he called down to Harding. Harding, still soaked from his swim, still shivering despite the blanket wrapped around his shoulders, nodded. "Positive. She'll hold. Just take it slow." Ashford didn't look convinced, but he gave the order. The Churchill rolled forward, its tracks clanking on the steel panels, its engine roaring. The bridge creaked under the weight. The pontoons dipped, sinking several inches into the water. The entire structure swayed, flexing like a living thing. Inside the tank, the crew held their breath. The driver, a corporal named Davies, gripped the controls so tightly his knuckles turned white. The gunner, a young private named Mills, closed his eyes and prayed. The loader, a veteran named Thompson, just cursed steadily under his breath. The tank moved forward, slowly, carefully, one track length at a time. The bridge continued to creak and sway, but it held. Harding had calculated that the bridge would sag by about 6 inches under a full load. It sagged by 5.8 inches. Close enough. The Churchill reached the center of the bridge, the point of maximum stress, and for a moment everything seemed to hold its breath. And then it kept moving, rolling forward, reaching the eastern bank, climbing up the muddy slope. The crew erupted in cheers. Ashford stood in the turret, waving his cap, grinning like a madman. On the western bank, the sappers cheered too, exhausted men finding the energy to celebrate, to shout, to slap each other on the back. They had done it. The bridge worked. More tanks followed. Churchills, Shermans, Cromwells. One after another they rolled across the bridge, their treads clanking on the steel panels, their engines filling the air with diesel smoke. Each tank that crossed was a victory, a vindication of Harding's calculations, a testament to the skill and courage of the sappers who had built the bridge in the dark. By 7:00 a.m., an entire tank brigade had crossed, over 50 tanks, along with dozens of trucks, jeeps, and artillery pieces. By 8 a.m., the eastern bank was secure, and the Germans, stunned by the speed and scale of the crossing, were beginning to retreat. Operation Plunder was a success. The Rhine, Germany's last great natural barrier, had been breached. And it had been breached not by overwhelming force, not by some brilliant tactical maneuver, but by engineering, by planning, by a group of men with wrenches and blueprints who had refused to believe that something was impossible. The cost and the legacy, remembering the fallen. But for all the triumph, for all the celebration, there was a cost. War always has a cost. 7 sappers were killed during the construction of the bridge. 3 were hit by artillery fire, shells that landed among the men as they worked, tearing bodies apart, leaving nothing but blood and twisted metal. 2 drowned when a pontoon capsized, the cold water and the heavy equipment dragging them down before anyone could reach them. 1 was crushed by a falling panel, a moment of inattention, a slip on the muddy ground, and 600 pounds of steel falling like a guillotine. 1 was shot by a German sniper, a single bullet through the head, death so quick he probably never knew what hit him. Their names are recorded in the archives of the Royal Engineers, preserved in fading ink on yellowing paper. Private Thomas Whitley, age 22, from Manchester. Corporal James O'Connor, age 27, from Dublin. Lance Corporal David Hughes, age 24, from Cardiff. Sapper Michael Brennan, age 19, from Glasgow. Sapper Robert Clark, age 21, from Birmingham. Sapper Henry Lawson, age 26, from Liverpool. Sapper George Mitchell, age 23, from London. They were sons, brothers, husbands, fathers. They were builders, not fighters. They had joined the sappers because they wanted to create, not destroy. They had skills that would have served them well in peacetime, skills that could have built houses and bridges and roads. But they died building a bridge in the dark, under fire, in a war that was not of their making. Harding never forgot them. After the war, when he returned to England, when he tried to resume his quiet life as a civil engineer, he visited their families. He traveled to Manchester, to Dublin, to Cardiff, to Glasgow, to Birmingham, to Liverpool, to London. He sat in modest parlors and cramped kitchens, drinking tea, looking at photographs of young men in uniform, listening to mothers and fathers and wives and children talk about the men they had lost. He told them what their sons and husbands and fathers had done. He told them about the bridge, about how it had been built in one night, about how it had allowed an entire army to cross the Rhine, about how it had shortened the war, saved thousands of lives. He told them that their sacrifice had mattered, that it had made a difference, that it would not be forgotten. And every year, on March 23rd, the anniversary of the crossing, Harding would raise a glass in their honor. He would stand alone in his study, looking at a photograph of the bridge, and he would speak their names aloud, one by one, a private ritual of remembrance. Because they were the real heroes. Not him. Not the generals who planned the operation, not the soldiers who crossed the bridge, but the men who built it, who gave their lives so that others could live. That was the cost. 7 lives, 7 families shattered, 7 futures erased. And Harding carried that cost with him for the rest of his life, a weight that no amount of success could ever fully lift. The amphibious gamble, the Buffalo cruise. But the bridge was only half the story, because before the sappers could build, the infantry had to cross, and they crossed in the most unlikely vehicles imaginable. Buffaloes. The Buffalo, officially called the Landing Vehicle Tract, or LVT, was an American design, born out of the desperate need to land troops on defended beaches in the Pacific. It was a strange hybrid, part tank and part boat, with tracks like a tank, but a hull like a boat. It could drive on land, then drive straight into the water and keep going, its tracks churning through the waves, its engine roaring. The British had acquired hundreds of them for Operation Plunder, and on the night of March 23rd, they were the first wave, the vanguard, the men who would establish the foothold that the bridge needed. Inside each Buffalo, 30 men sat in near darkness, packed shoulder to shoulder in the open cargo bay. The vehicle rocked and swayed as it entered the water, and the men held on to whatever they could find, the sides of the hull, each other's uniforms, their rifles. The engine roared, drowning out all other sound. Water sloshed over the sides, soaking the men, cold and shocking. Some men prayed, whispering words to gods they weren't sure they believed in. Others vomited, their stomachs rebelling against the motion and the fear. But they all held on, because there was nothing else to do. The crossing took 10 minutes. 10 minutes that felt like hours. 10 minutes of terror. German machine guns opened fire, the bullets pinging off the armor, some finding gaps, punching through the thin steel, and men screamed. Tracer rounds lit the sky, red and orange streaks that seemed to come from everywhere at once. Shells exploded in the water, sending up geysers of spray that drenched the men, that rocked the buffaloes, that threatened to swamp them. But the buffaloes kept moving. They were slow, ungainly, vulnerable. But they were tough. The armor, though thin, was enough to stop most small arms fire. The hull, though it leaked, was buoyant enough to stay afloat. And the drivers, hunched over their controls, peering through narrow vision slits, kept the engines roaring, kept the tracks churning, kept moving forward no matter what. And they made it. One by one, the buffaloes reached the eastern bank, their tracks finding purchase on the muddy slope, their engines straining as they climbed out of the water. The ramps dropped, and the infantry poured out, scrambling up the bank, rifles raised, disappearing into the darkness. By 3 a.m., over 1,000 men had crossed. By 4 a.m., they had secured a perimeter, a fragile foothold on the eastern bank, a circle of foxholes and machine gun nests that held back the German counterattacks. And by 5 a.m., they were holding the line, waiting for the tanks, waiting for the bridge. The Buffalo crews didn't stop. They turned around and went back for more. Again and again they crossed the Rhine, ferrying men, ammunition, supplies. Each crossing was as dangerous as the first. The Germans never stopped firing. The shells never stopped falling. But the buffaloes kept moving. By dawn, they had made over 50 trips. Some buffaloes were hit, their armor pierced, their engines destroyed. Some sank, taking their crews with them. But most made it. And without them, the bridge would have been useless, because a bridge without infantry to protect it is just a target, a long, thin target that the Germans would have shelled into oblivion. The Buffalo crews were the unsung heroes of Operation Plunder. They didn't build the bridge. They didn't cross it in tanks. But they made it possible. They established the foothold. They held the line. And they did it in vehicles that looked like they had been designed by a committee that couldn't decide whether they wanted a tank or a boat. So they built both and hoped for the best. The German response? Stunned and outmaneuvered. The Germans were not idle. They knew the Allies were coming. They had prepared. They had fortified the eastern bank, positioned their artillery, laid their mines. They had blown every bridge and believed that the Rhine was uncrossable, that it would hold the Allies back for weeks, maybe months, giving Germany time to regroup, to bring up reinforcements, to prepare a final defense. But they had not expected this. Not the speed, not the scale, not the audacity. When the first reports came in that the British were crossing the Rhine, German commanders were skeptical. Crossing the Rhine at night? In amphibious vehicles? Impossible. But then the reports kept coming. Hundreds of vehicles, thousands of troops, and then the bridge. Bridge built in one night, in the dark, under fire. The German High Command was stunned. They ordered immediate counterattacks, artillery barrages, airstrikes, infantry assaults. But it was too late. By the time the German forces mobilized, the bridge was complete. The tanks were across. The perimeter was secure. The Germans fought hard. They were not cowards. They were professional soldiers, many of them veterans of years of war, men who had fought in Russia, in North Africa, in France. They launched several counterattacks over the next few days, trying to break through the Allied perimeter, trying to reach the bridge and destroy it. But they were outnumbered, outgunned, and demoralized. The Rhine, their last great defense, had been breached. And it had been breached not by overwhelming force, not by some brilliant tactical maneuver, but by engineering, by ingenuity, by a group of men with wrenches and blueprints who had refused to accept that something was impossible. The psychological impact was devastating. If the Allies could cross the Rhine in one night, what else could they do? If a bridge could be built under fire, in the dark, what other miracles were they capable of? The German soldiers, already exhausted from years of war, already demoralized by constant retreat, began to lose hope. And an army without hope is an army that has already lost. The unsung heroes, remembering the sappers. History remembers the generals. Montgomery, with his beret and his meticulous planning. Eisenhower, with his broad smile and his political acumen. Patton, with his pearl-handled pistols and his aggressive tactics. But history often forgets the engineers, the sappers, the men who built the roads, cleared the mines, constructed the bridges. Men like William Harding. Men like the 200 sappers who worked through the night on the banks of the Rhine. Men like the Buffalo crews who crossed the river again and again under fire. They didn't seek glory. They didn't want medals. They just wanted to do their jobs, to do them well, to go home when it was over. And they did their jobs brilliantly. After the war, Harding returned to Yorkshire. He resumed his work as a civil engineer, designing bridges for the rest of his life. Quiet bridges, peaceful bridges, bridges that carried families on holiday, not tanks to war. He married his sweetheart, a woman named Elizabeth who had waited for him through 4 years of war. They had 2 children, a son and a daughter. He lived a quiet life, a good life, a life that from the outside looked utterly ordinary. He died in 1982 at the age of 68 of a heart attack while working in his garden. His obituary in the local newspaper mentioned that he had served in the war, that he had been a sergeant major in the Royal Engineers. But it didn't mention the Rhine. It didn't mention the bridge, because Harding never told anyone. He didn't think it was important. He didn't think anyone would care. But it was important. It was vitally important. Because that bridge, built in one night by men who refused to quit, changed the course of the war. It allowed the Allies to pour into Germany, to encircle the Ruhr, to cut off Germany's industrial heartland. It shortened the war by weeks, maybe months. It saved thousands of lives, Allied and German lives that would have been lost in a prolonged campaign. And it proved that sometimes the most powerful weapon in war is not a gun or a bomb or a tank, but a blueprint and the will to see it through. The mathematics of the impossible. Engineering under fire. Building a bridge across the Rhine wasn't just a feat of courage. It was a feat of mathematics, of engineering, of understanding the forces that act on structures and the limits of materials. Harding had spent months calculating every variable, every force, every stress. The width of the river, 400 yards, or 200 feet. The depth, 15 feet in most places, but up to 30 feet in the center channel. The current, 5 miles per hour, or 7.3 feet per second, fast enough to exert significant force on the pontoons and the bridge structure. The weight of a Churchill tank, 40 tons, or 80,000 pounds. The load capacity of a single Bailey panel, 10 tons, or 20,000 pounds, which meant the bridge needed to be at least 4 panels wide to support a tank, with a safety margin. But it wasn't just about width, it was about distribution. The weight of the tank had to be spread evenly across the panels. If too much weight concentrated in one spot, the bridge would buckle, the panels would bend, the connections would fail. Harding designed the bridge with a double truss system. Each panel was reinforced with a second layer, doubling the load capacity to 20 tons per panel. This meant the bridge could support a 40-ton tank with a safety margin of 100%, enough to account for dynamic loads, for the impact of the tank's movement, for the vibrations caused by the engine and the tracks. He also calculated the spacing of the pontoons. Too far apart, and the bridge would sag in the middle, creating stress concentrations that could cause failure. Too close together, and the pontoons would interfere with each other, creating turbulence in the water that could destabilize them. He settled on 30 feet, a spacing that balanced support and stability. And then there was the current. The Rhine's current was strong enough to push the pontoons downstream, to drag them away from their anchors. Harding solved this by anchoring each pontoon with steel cables attached to concrete blocks on the riverbed. But the cables had to be the right length. Too short, and the pontoons would be pulled under by the weight of the blocks. Too long, and they would drift downstream, pulling the bridge out of alignment. Harding calculated the exact length based on the depth of the river, the weight of the pontoons, the force of the current, and the angle of the cables. He used trigonometry, calculus, principles of fluid dynamics. He filled notebooks with equations, with diagrams, with calculations that he checked and rechecked until he was certain they were correct. And they were. When the first tank crossed, Harding stood at the center of the bridge, feeling it flex beneath the weight. He had calculated that the bridge would sag by about 6 inches under a full load. It sagged by 5.8 inches. Close enough. The bridge held. The mathematics worked. And an entire army crossed the Rhine because one man had done the math correctly. The human cost, 7 lives, thousands saved. But for all the mathematics, for all the planning, for all the engineering brilliance, war is ultimately about people. And people die. 7 sappers were killed during the construction of the bridge. 7 men who had families, who had dreams, who had futures that were erased in an instant. Private Thomas Whitley, age 22, from Manchester. He had been a carpenter before the war, had learned his trade from his father, had planned to open his own shop when he got home. He was killed by an artillery shell that landed among the men as they worked, tearing his body apart, leaving nothing for his family to bury. Corporal James O'Connor, age 27, from Dublin. He had been a welder, had worked in the shipyards, had a wife and a baby daughter he had never seen. He drowned when a pontoon capsized, the cold water and his heavy equipment dragging him down before anyone could reach him. Lance Corporal David Hughes, age 24, from Cardiff. He had been a mechanic, had a gift for understanding how machines worked, had dreamed of designing cars. He was crushed by a falling panel, a moment of inattention, a slip on the muddy ground, and 600 pounds of steel falling like a guillotine. Sapper Michael Brennan, age 19, from Glasgow. He had been a student, had been studying engineering at university when the war broke out, had enlisted because he wanted to do something useful. He was shot by a German sniper, a single bullet through the head. Death so quick he probably never knew what hit him. Sapper Robert Clark, age 21, from Birmingham. He had been a bricklayer, had strong hands and a stronger work ethic, had planned to marry his sweetheart when he got home. He drowned when a pontoon capsized. His body never recovered, lost somewhere in the cold, dark waters of the Rhine. Sapper Henry Lawson, age 26, from Liverpool. He had been a plumber, had a wife and 2 young sons, had written them letters every week telling them he would be home soon. He was killed by an artillery shell, his body torn apart, his letters found in his pocket, stained with blood. Sapper George Mitchell, age 23, from London. He had been an electrician, had worked on the underground, had a quick wit and a ready smile. He was killed by an artillery shell, his body never found, presumed buried under the mud and debris. 7 lives, 7 families shattered, 7 futures erased. But because of their sacrifice, because of the bridge they helped build, thousands of lives were saved. The Rhine crossing shortened the war. It allowed the Allies to advance into Germany faster than anyone had expected. It cut off German supply lines, encircled German armies, forced German commanders to make desperate decisions that hastened the end of the war. And every day the war ended sooner was a day that thousands of people, soldiers and civilians, Allied and German, did not die. That was the calculus of war. 7 lives given so that thousands could be saved. It was not fair. It was not just. But it was the reality. And Harding carried that reality with him for the rest of his life, a weight that no amount of success could ever fully lift. The bridge that changed everything. The final push. The Rhine crossing was a turning point, a moment when the momentum of the war shifted irrevocably in favor of the Allies. After Operation Plunder, the German army was in full retreat. The Allies poured across the Rhine, not just at the bridge that Harding built, but at dozens of other crossing points up and down the river. Within days, they had established bridgeheads all along the eastern bank. Within weeks, they had encircled the Ruhr, Germany's industrial heartland, trapping over 300,000 German soldiers. Within a month, they had reached the Elbe River, deep in the heart of Germany. Within 6 weeks, the war in Europe was over. On May 7, 1945, Germany surrendered unconditionally. The war that had begun in September 1939, that had consumed the world for nearly 6 years, that had killed tens of millions of people, was finally over. And it all started with a bridge. A bridge built in one night by men who refused to believe it was impossible. A bridge that shouldn't have worked, but did. A bridge that was too sneaky, too audacious, too brilliant to fail. Today, there is no monument to Harding's bridge. The bridge itself was dismantled after the war, its panels reused elsewhere, its pontoons deflated and stored. The site where it stood is now a quiet stretch of riverbank, indistinguishable from any other. There is no plaque, no marker, nothing to indicate that something extraordinary happened there. But the memory remains. In the archives of the Royal Engineers, there are photographs of the bridge, grainy black and white images that show a thin line of steel stretching across the Rhine. In the Imperial War Museum in London, there is a section of Bailey panel, rusted and worn, with a small placard that explains its significance. And in the hearts of the men who crossed that bridge, the soldiers who rode in tanks across that thin line of steel, who looked down at the dark water rushing beneath them and marveled that they were still alive, the memory remains. Because sometimes, history is not made by the loudest voices or the biggest guns. Sometimes it is made by quiet men with wrenches and blueprints who look at a river and see not an obstacle, but a problem to be solved. And when they solve it, when they build the impossible, they change the world. That is the story of the Bridge Too Sneaky, the story of how British sappers floated an entire tank brigade across the Rhine overnight, the story of William Harding and the 200 men who refused to quit, the story of courage, ingenuity, and the power of a well-built bridge. Because in the end, War is not just about destruction. It is also about creation. About building something that lasts, even if it only lasts for a few weeks. About connecting one side to the other. About bridging the gap between where you are and where you need to be. And that is what Harding did. He built a bridge. And in doing so, he built a path to victory, a path that thousands of soldiers walked, a path that led to the end of the war and the beginning of peace. That is his legacy. Not a monument of stone or bronze, but a memory, a story, a reminder that sometimes the most important victories are won not with guns, but with ingenuity, not with violence, but with skill, not with destruction, but with creation. And that is a lesson worth remembering.